Welcome TechbrothersIt. In this video, we are going to learn what are RDD partitions in PySpark. So here is the definition. A partition in Spark is a logical chunk of your data. RDDs are split into partitions and processed in parallel across nodes in a cluster. More partitions, more parallelism. So if you have more partitions, more parallelism will happen. But again, depends on number of cores. If you have created a lot of partition, but you do not have a lot of cores, then it's not going to run all of them in parallel. So we'll take a look down in the definition here. When you are using this function of parallelize, and here you will be providing the data, and then you will say number of partitions. Any number you will provide here, though, that will be the number of partition will be created for your RDD. If no partition number is provided, Spark uses the default parallelism level, which is typically equal to the number of cores available to the application. So if I go back to my cluster here, and here is my cluster, if I will click here, I have 14 GB RAM and 4 cores. So each partition will be equal to 1 core. So in this case, if I will not provide the number of partition, then it will create a RDD with the 4 partition, as I have 4 cores. Now let's take a look on the repartition function. Creates a new RDD with exactly n partitions via full shuffle. So just remember that as it is going to be full shuffle, so data will be shuffling between different nodes. Then you need to see if it is really needed and what benefits you are getting by doing the repartition. Coalesce, on the other hand, merges partition to reduce their numbers without full shuffle. So it is faster when reducing. And now also that's some specific scenario has to be there. Maybe you are creating a file and writing the data to the CSV file or any other file, and you have too many partitions, and each partition will be written to the separate file. Now in this case, maybe you will use coalesce and merge them together and create a less number of files depending upon your scenario. Always verify current partition count using RDD.getNumPartitions. So this function will give you total number of partitions in your RDD. So let's go ahead and take a look further. As I was saying, it depends on number of cores. So Spark allows more partition than CPU cores. So if you see right here, I have 4 cores, but I can create the partition maybe 20 partition. But that doesn't mean that it's going to take a 20 partition and start processing them at the right away. So it will take 4 partition and then process four of them. As I have 4 cores, then go for the next 4s and keep going. Tasks are queued only as many partitions run in parallel as the cores available. So if you have 4 cores, your 4 partition will execute. Remaining tasks wait and are picked up once the cores are freed up. This enables load balancing and fault tolerance. So just remember that if you don't have so many cores and you don't want to go ahead and create partitions, a lot of partitions. So think about it. Each partition is going to be equal to 1 core pretty much. Now here what we are doing in this case, we are creating an RDD with the 2 partitions. And I have this data, so I have names, and then I'm saying RDD, that's the name of my RDD, equal to SC. So this is our Spark session. Then we say parallelize, and then we say data, and then 2. So now once we run this, what's going to happen is going to execute and create our RDD with the 2 partition. So right here, actually I did not print anything, so I should be printing this part as well. So I'm going to execute now. So you will see the number of partition for this RDD is equal to 2, as we have provided the number of partitions right here. So if you want to change, you can change, and that's your choice. Now if we want to repartition and say 2 to 5, so we had 2 partition, now we want to go 5. So I'm creating a new RDD underscore repart using the existing RDD and say repartition, and how many partition I want? 5. So it's going to create a new RDD with the 5 partition, and here it is. And then we can use RDD underscore repart and get a number partition. So this is going to show us the total number of partition in this newly created RDD. So it's going to show us 5. So you can see right there. So again, it is a full shuffle, so remember that it is expensive process. You need to really have some solid reason for the repartitioning. Now if we use in coalesce and we want to go back to the two partition, we have RDD coalesce. This is a new RDD we created, and this is RDD repart that has a 5 partition we just did right here, right? Now we want to go to the two partition, we can simply, or even let's say we want to go to one partition, we can do that. And then here I'm printing and saying RDD coalesce dot get num partition. So get me the total number of partitions in this RDD. So you can see that I have a total number of partition equal to 1 as I changed here 1. So I did not make the changes to the print statement, that's why it is shown as on top too. So if you want to change that, you can do that as well. Okay, so total number of partition in this RDD is equal to 1. And in step 5 we can show how data is spread using a gloom. So we can use this function to see the data across different partition, and you can see right there I'm running, so everything is in a single partition right there. So there isn't really much to show here, but we can put into the, if we have a large data and we could see, let's say if I want to do here, instead of coalesce, we will go back here and say partition right there, right? And now we create the 5 partition here, and then we will use the coalesce, and then here in the coalesce I will say 3. Okay, now we are creating a 3 partition, but again it doesn't, as the data is small, it doesn't really mean that is each partition is going to have data. So now we have 3 partitions in this, and if I want to see the data, you can see right there. So in the first one you see this is empty, and then everything is in the third partition right there. So if you have a large amount of data, then you will see more kind of data in every partition, but right now we don't have much, so you are seeing. So this is how it is spread as of now. We can see by using a gloom function here. I thank you very much for watching this video. I hope this video is helpful and you understand what are the RDD partitions and how to use them, and I will see you guys in next video.